Yep, I'm live once again. I don't know what was the issue earlier. Really sorry, guys. Alright, posted it on Twitter as well. Now, yeah. We were at friend function, right? So, what are friend functions and friend classes? Friend functions are special non-member functions that are granted access to private and protected members of a class. Similarly, a friend class is a class that has access to another class private and protected members. They're useful when two classes of functions need close cooperation without making everything public. So we'll just see an example as well. I'll just quickly share my VS Code. Friend function. So suppose we have a class B. Now we have a class A. So what was friend function again, guys? Those they are special non-member functions that are granted access to the private and protected members of a class. We can similarly have friend classes as well that have access to another class's private and protected members. It is useful when two classes or function need close cooperation without making everything public. So suppose in class we have like integer a variable which is private by default. In public we can have function called as void a comma b. A and B are the data types, you can say, not data types. Uh, the objects, how should I say it? A is a class. Mm, we are basically passing the classes uh, which friend function should be able to access. Now, friend function is always used with the help of friend keyword. So, friend void a comma b. Similarly, we have class B. In class B, we can have something like int b public friend void fun. Similarly, you can a comma b. The reason why we declared class B earlier is when the compiler starts to run from top to bottom, it will see that B is declared over here but not anywhere else. So it will generate a compile time error. To avoid that, we have initialized class B earlier. So what this says is that I'm initializing class B as of now, but it is going to be implemented later on. So this bypasses the compile time error. Now I can simply implement the fun method, which basically has a class of A1. So we have an object O1 of type A. A is basically class. Similarly, we have an object of type class B. Now we can simply do cout o1.a plus o2.b. This way we are able to access the internal, what should I say, data and methods of two different classes without making everything public. Now we'll see what are the types of inheritance. I'll just quickly close my VS Code. Yep. So inheritance are of various types. The first one is single inheritance when you have only one parent class and one child class. Child class inherits from one base class. Multi-level inheritances, a class inherits from another derived class. So it's like parent, children, grandchildren. You can think something like that. In multiple inheritance, we have like a child inherits from more than one base class, so it's like V shape. Two parent class, one child class. In hierarchical inheritance, multiple child classes inherit from the same class. So you can think of it like in the shape of a one parent class, multiple child classes inheriting from the same. And hybrid inheritance is combination of two or more above. Type depends upon this. The type supported depends upon the programming language in use. What are the limitations of inheritance? So, as for limitation of inheritance, while it's powerful for code reusability, it comes with its own trade-off. First one is performance overhead. The program may take longer to process because it needs to navigate through multiple class layers. As we have read in multi-level inheritance, there could be like multiple grand classes and all. So that is one of the limitation. Second one is tight coupling. So the child and base classes become closely linked. So change in base class can force changes in all derived classes. Third one is complexity. Inheritance hierarchies can become hard to manage if not implemented carefully. They can lead to unexpected bugs and unintended behavior. Next, what is a subclass? A subclass is a class that inherits properties and behaviors from another class called the superclass. It can also have additional features or override the inherited ones. Fine. Subclass are also known as child classes or derived classes. Now, what are superclass? It's a class whose properties and behaviors are inherited by one or more subclasses. It defines the common features that can be reused by its subclasses. Subclasses are also called parent classes or base classes. Now, there can be a question in interview like how does C++ support polymorphism? So, in that case, the interviewer is basically asking what are the types of polymorphism, right? So, compile time polymorphism achieved by function and operator overloading. In this case, the decision of which function to call is made at the compile time. For example, we can have this. And simpler write it in a better way. We have void print index. Similarly, we have void print into double y. So if based upon the type of value passed in the print function, the according print function will be called. So compiler chooses which print to call based on the argument type. Okay. Now runtime polymorphism achieved by function overriding using virtual functions and inheritance. In this case, the function called is resolved at runtime using the virtual method table mechanism. Now, I generally the interview doesn't go deep into this virtual method table mechanism. You can skip mentioning this as well. If the interview is too much excited, he'll definitely ask you about this. But yeah, so let's skip that for now. Example is class base. We have a pure virtual function. Runtime polymer. Oh, we don't have pure virtual function. It's just a normal virtual function. If the function is executed depends upon the depending. If the function to be executed depends upon the type of object wanted to at runtime. Next, what is virtual function and pure virtual function? So a virtual function is a member function in a base class that you expect to override in a derived class. It enables runtime polymorphism via the vtable mechanism in C++. Once again, it's not mandatory to go in depth of understanding the vtable mechanism, but yeah, you can refer in your free time. We declare it with the virtual keyword in the base class. When called to the base class pointer, a reference the derived class version is executed if overridden. So suppose I avoid display override, then and if I instantiate my object with the help of base class pointer pointing to the derived class pointer. I don't know if that made sense, but yeah. In short, what I'm saying is suppose I write something like base b equal to new derived and blah blah, and then I try to call derived, then I try to call display method, then this particular method will be called. Alright. I just have one doubt that where is my chat GPT? if I call derived base b equal to new derived b dot display, what is that? So if I don't write the virtual keyword and I write the display method, so it is going to call the base display method, by the way. A pure virtual function is a virtual function with equal to 0 at the end of the declaration, meaning it has no implementation in the base class and must be implemented in the derived class. A class with at least one pure virtual function becomes an abstract class and cannot be instantiated, right? And now class shape, for example, we can see we have implemented all of these in the example where we have defined all the four pillars. So I'm not rewriting this in VS Code. So ensure virtual function has a definition can be overridden. Pure virtual function no definition must be implemented in derived class. How much memory does a class occupy? One more second. Yeah, so in C++, a class by itself does not occupy memory. It's just a blueprint or a template for creating the objects. The memory is allocated only when we create an object, and the size depends upon the non-static data members of the class. It started raining. Static members are not part of the object memory. Static members are not part of the object's memory footprint. They're stored separately in a data segment. We'll come to the static part later. It's there in my notes. So yeah. Is it always necessary to create data objects from class? No, it's not necessary. If the class contains only static methods or static data members, we can access them directly using the class name without creating an object. However, if we want to access non-static members, we must create an object because those members belong to instance, not the class itself. What is constructor? A constructor is a special member function in class that is automatically invoked when an object is created. Its primary purpose is to initialize object's data members. Unlike regular functions, constructors don't have return type. Their name must exactly match the class name. You can see the example when we create an object of base, this constructor will be executed. What are the types of constructors in C++? So in C++, we basically have four types of constructor. One is default constructor, a constructor with no parameters automatically created by the compiler. We don't define any. It initializes member to default values. For example, you can see we did not mention any constructor, but the compiler internally will create another constructor. Next is non-parameterized constructor. In this case, we define our constructor and we can write any kind of initializations or declarations inside. So it is explicitly coded by developer. In parameterized constructor, we accept arguments, so we initialize object with specific values at creation. You can see here. In copy constructor, this is important, creates a new object as a copy of existing one, usually taking a reference to an object of the same class. So we'll just write this in VS Code as well. Copy constructor. So suppose we have something like class A, semicolon, public index. Now suppose we are initializing parameterized constructor x is equal to value, and yeah, let's keep it this way for now. Now in main return 0 as always. Suppose we have a object 1 as 50, so we are having x is equal to 50. This is my original. Now I'm having a object 2 is equal to object 1. This is what it will basically call my calls copy constructor. Since I did not define any copy constructor, this probably give me an error, comparative error. What this is do is when I write equal to object 1, it is basically accepting an object of type A, and then I'm writing x is equal to object dot x. So now what happens is if I do something like cout object2 dot x, this is going to give me output as 50 because both objects are pointed to the same variable. I'll just make sure, and I'll just make sure if I'm going correct. Here object 2 and object 1 are both pointing to the same number variable, right? This is what copy constructor does, right? Now, if you don't define a copy constructor in C++, if you don't define a copy constructor, C++ provides a default one, but in cases involving dynamic memory, we often implement it ourselves to avoid shallow copying. I'll just try to run this. What is the output? I will clarify what copy. A copy constructor creates a new objects and performs a member-wise copy. Creates a new objects and performs a member-wise. Copy of an existing value type members are copied to value. They do not alias the same storage in your animal class. Not animal. Value copy. I think it misunderstood. Control C. Control C. Happy to help her now. Mm. So considering Arnav's request has been completed, let's get back to our this. Oops. Usually taking a reference of the object of the same class. We tend move object to gets its own copy, changing object 2 dot x won't affect object 1 dot x. Only pointer members are handles to shared members by default. Oh, so shallow copy occurs. Creates an object profile member copy. Shallow copy and existing one. So since shallow copy is occurring, so we'll get a new memory block with the same value. Only pointer members share by default because the pointer value is copied to the object. Then both objects point to the same allocation. We'll come to deep copy and shallow copy later as well. So consider the copy constructor is basically doing a shallow copy. So yep, an example of copy constructor. I'll just quickly add my Obsidian, not BS Code. Yeah, so I've written the same as well here. Can we overload the constructor in a class? Yes, constructor overloading is possible in many OOPS languages. It means defining multiple constructors in the same class, but with different parameters list, either by number of params or types of params. This allows us to create objects in different ways. For example, you can see again, I just write, for example, now what is destructor? A destructor is a special method that is automatically called when an object is explicitly destroyed. Its job is to release resources, close files, free memory, or perform cleanup tasks. In C++, it has the same name as the class but prefixed with this baby, which is also called tilde symbol. For example, you can see the example here once again. Can we overload the destructor in a class? Nope. A class can only have a class can have only one destructor and it cannot be overloaded. Because it doesn't take parameters and cannot return a value, the language ensures there is single predictable cleanup mechanism. One second, guys. Okay, we are on the 32nd question. I think that's almost half of my PDF. And we are having more like how many? 48 questions. 42nd, 48, right? More or less 16 questions. I'm planning it to complete before 12 p.m. So I have something like 1 hour almost. Alright, let's continue. What are access specifiers and what is their significance? Access specifiers in C++ are keywords that define the accessibility of class members. The three main ones are public, protected, and private. They help implement encapsulation and data hiding by controlling how data and methods can be accessed from outside the class. They help implement encapsulation and data hiding by controlling how data and methods can be accessed from outside the class. For example, private members are accessible only within that class. Protected members can be accessed within that class and derived classes. Public members can be accessible from anywhere. This is fundamentally what is garbage collection in OOPS world. In OOPS, objects occupy memory, and if unused objects are not properly released, it can lead to memory leaks. Garbage collection is the process of automatically reclaiming memory occupied by objects that are no longer reachable or in use. While languages like Java have built-in garbage collectors, in C++, memory management is manual, meaning we explicitly delete memory using delete keyword. Proper memory handling ensures efficient resource usage and prevents system crashes due to memory exhaustion. What is an exception? An exception is an unexpected event that occurs during execution of a program, disrupting its normal flow. It usually arises when the program encounters a situation it wasn't designed to handle, such as an invalid input, division by zero, or accessing an out of bound array index. Essentially, it signals that something has gone wrong at runtime. For example, we can use try-catch block to handle the particular exception, which is our next question. What is meant by exception handling? Exception handling is the mechanism used to detect and manage unexpected situations without crashing the program. Instead of terminating abruptly, we can anticipate possible errors, catch them, and define alternative flows or recovery actions. The most common approach is using try-catch blocks, where the try section contains code that might throw an exception, and the catch section defines how to handle it. You can see the try-catch example here. In the try block, we are having this function divide by 0. If b is equal to 0, we'll just throw a runtime error. If I get a runtime error, I'll simply just catch it and yeah, program continues. Can we run a Java application without implementing the OOPS concept? Strictly speaking, the Java application must have at least one class since Java is a class-based language. So when OOP is the core design paradigm of Java, it is possible to write and run small Java scripts without actively applying all OOPS concept. But you cannot avoid having at least one class definition. In the sense, if you have the small program, we need not implement inheritance and abstraction and all those stuff. But yeah, the minimum requirement is we must have a class. So this is what my answer basically says. It doesn't use all feature, but it requires a class for that. Now explain early binding and late binding in C++. I'm just seeing what all things are left to cover up. Right, so in C++, binding means deciding which function to call for a given function call. Early binding, also known as static binding, this function call is resolved at compile time. This happens when normal function calls, with normal function calls and function overloading. Early binding is nothing but like compile time polymorphism. In other words, compiler decides at compile time which function to call. You can also write the compile time polymorphism example here for more clarity's sake. Reference to page 2, that's early binding. In late binding, that is the runtime polymorphism, this happens when you use virtual functions. We call them a base class pointer / references. If I see how can a base class pointer call a child class pointer? Oops. For example, you have this virtual keyword, void show, you are overridden, base star pointer p, derived d, you then point your pointer to the address of d, now pointer dot show means this pointer is pointing to the object d, and when you call this show method, since it's virtual, so it could be like, uh, access made the last, so it will just override this and it will call this. If the compiler knows that PTR is a base type, but it doesn't decide at compile time which version of show to call. At runtime, since PTR points to derived value, it calls to this. That's sleep manual. Now I have to explain deep copy and shallow copy. We have already discussed it. So what shallow copy does is it copies all member values bit by bit, including pointers. This means if two objects share the same pointer, changes made through one object affect the other. Default copy constructor provided the compiler does a shallow copy. So as you can see, star object to data changes object one as well. Probably not. This rises it out. Just please share my VS Code as well. Field. No, what happened? 50-50, right? Now check 2 dot x is equal to 40. Control C, Control V. Let's suppose are different. Now I'll stop sharing VS Code. If two objects share the same pointer, changes made through one object affect the other. Default copy constructor. I think this point is wrong. The second point is wrong. Alright. It copies member values bit by bit, including pointers. If a class has pointer members, both objects will end up pointing to same memory location. This means modifying the data through one object will affect the other, and it can also lead to issues like double deletion. Pointer members, na? Give example of pointer members. So pointer members means basically this. Pointer member, it's initialized. object 2 dot data. Yeah, since it's a pointer member, both objects will end up pointing to same memory location. So since I'm modifying object 2 dot data, it's giving me 20, but for normal variables it's working fine. When object 1 and object 2 go out of scope, delete is called by some same or I hope this is clear because when I'm clearing object 1, that particular memory is deleted. Now when object 2 is also we are clearing after the function is ended, since that particular memory is already deleted, it will give undefined behavior. And deep copy, instead of copying the pointer as it is, we allocate new memory and copy the contents. This ensures each object has its own independent copy. So till here everything is same. What we do is during the copy constructor, we need not write this const particularly. We can just simply get pass by reference and we can write new memory plus copy value. Yeah, so this is it. Whenever a class or pointers are dynamically allocated and we want each dimensional copy of data without interference, we do deep copy. Explain diamond round with example. It occurs in average inheritance. One child, one parent, two child, one grand class. Now without special handling, D will end up with two copies of A. And through B, once you see this causes ambiguity. You can see compiler doesn't know which method to call. We solve this problem by using the concept of virtual inheritance by making C, B, and C inherit virtually from A. C++ ensures there's only one shared instance of A in hierarchy. So we write virtual keyword over here. Object.d shows single instance and rightmost class is considered. So multiple inheritance from a base case, common base causes duplicate copies and ambiguity. Solution is use virtual inheritance to ensure one copy remains. Now we should tell the output of the following code snippet. We have one class, we have another child class, two child classes implementing two func2, then one grandchild class having function 3. Now if I call function 2, what could be the output? If you carefully see, this is not a diamond problem since parent function is different. So it's like only two parent classes and one child class trying to call the same method. So we can resolve this by telling the compiler exactly which version we want. We can do something like this. And now here we take another break. What is singleton design pattern, factory pattern, observer, procedural programming, difference, solid principles, initializer list, this 48. So I think we are left with like 9 more questions. Yeah, I think we are left with 8 more questions. We'll just continue this after like 10 to 15 minutes break, right? I just hope my net doesn't get disconnected again. Alright, singleton design pattern. I'm gonna do this. Not gonna show. Yes. live stream is there, right? So yeah, boy. Uh, Alright, I should be true to my words. It's 7:16, so I'm sorry guys for being 1 minute late. Let's continue. What is singleton design pattern? It ensures that only one instance of a class exists in the program and provides a global point of access to it. It's useful when exactly one object is needed, like a log or database or connection configuration manager. For example, you can see we declared with the help of static method. So this way we have only one instance of that whole particular class. The constructor is private, so no one can directly access and directly create an object of singleton. We hold static instance inside class. When get instance is called for the first time, we create an object. Any further instance, just any further calls, just return the same instance. So yeah, factory pattern provides an interface for creating objects, but let's subclasses decide whether which class to instantiate. It adds object creation, so client mode only depends on abstract type, not concrete implementations. For example, I have interface for creating objects. I have shape objects. My subclasses implemented those. Hides plan cron. Now, when I call any kind of now, if I have to make any shape like circle or square, I can simply return that. Okay, this is my factory pattern. Interfaces being implemented by subclasses. The observer pattern defines one-to-many dependencies. So when one subject changes state, all of its dependents, that is observers, are notified automatically. So again, I have an observer, I have a subscriber, which is a like update. Now with class channel the type observer. Void subscribe notify. Here we have channel subject and many subscribers. True. When the channel calls notify new video, all subscribers automatically get updated. What is subs again? It is my this vector. All the observer subscribers has not update message. Hmm. Channel. Explain procedural programming. How is it different from OOPS? Procedural programming, structured programming is basically making use of functions, equals, and while loops. Procedural programming is a paradigm that based on concept of functions, breaking down the program into small and reusable functions. Imperative means how to, declarative means what to achieve. Right. So the focus is on functions, data and functions are usually separate. Execution is generally top-down. For C language are right. That are organized. The difference is focus, data handling, reusability. An example. Difference between C and C++. C is a procedural programming language, while C++ is a multi-paradigm language that supports both procedural and object-oriented programming. C has no classes inheritance, whereas C++ have all of those. Now to explain solid principles. Solid principles. Single responsibility principle. It says a class should have only one reason to change, meaning it should do only one job. By the way, this is not very important, but just doing it for revision purpose. It should do only one job. Report generation. A class should do only one job. As for single responsibility principle over open close principle, class should be open for extension but closed for modification. Fine. L is list cost substitution principle. It says objects of a superclass should be replaceable with objects of subclass without breaking the program. If class B inherits class A, then anywhere in the program, these objectives should be also. You can refer the examples, I'm like not giving much focus to these. Interface segregation principle, it says clients should not be forced to depend on interfaces they don't use. Clients should not be forced to depend on interfaces they don't use. Clients should not be forced to depend on interfaces they don't use. Interface segregation principle. Devins, it says high level model should not depend on low level model, but should depend on abstraction. Again, you can refer the example. Last two questions remaining. What is the initializer list? In C++, when we say initializer list, we usually mean a constructor initializer list. It initializes class members before the constructor body runs. It's the syntax with colon after the constructor signature used to initialize data members before the constructor body. It's required for const members and it's also more efficient than assigning inside the constructor body. So suppose I have a class parent, I have a constructor defined. Now in class shell, what I can do is I inherit from my parent. Now I have an integer y. Now child int a comma b. Suppose I take two parameters in child a comma b. I'll simply call it parent a comma b. So parent a and y of b. What does this mean? I'll just simply do ChatGPT. So calling parent child constructor, what it does is calls the constructor of the base class parent a, and what it does with argument a, this initializes the data member y with child with value. Now here my constructor body is running. Difference between initialization using initializer list and assignment using constructor body. Look similar, but they are different how it works. Happens before constructor body executes. Members are directly constructed with given values. No overhead. First, members are default constructor. Then inside the constructor body, we assign values extra sharp, less efficient. Key example. So suppose I have a constant A and a reference member B. In an example, when I declare a constructor, I can simply write AX, BY. Works. But if I write something like this, it's gonna give error. Must be initialized in initializer list. They cannot be assigned later inside the constructor body. Performance different. So I hope this is clear, and yeah, this concludes our OOPS revision. So yeah, guys, take care. We'll meet next time with. We have a couple of more to revise as well. I'll just show you what we are left with. It's like DBMS, HTML, JS, MERN, others, Next.js, Node.express, OS, Python, React, REST API, SQL, and a couple of more. So yeah, many more live streams to be